Politicians. How's everyone doing today? Don't answer all at once. I can't read that fast. Yeah, gonna be prepping for my defense, which is on Monday. Of course, by prepping my defense, I mean I'm probably gonna get distracted by questions pretty quickly. And after all, that's what I'm here for. That is what I'm here for. What were we even debating yesterday? I feel like we were debating a bunch of stuff. Maybe we should continue those debates, or maybe not. Maybe it's futile to debate whatever the hell we were talking about. Maybe it's just total nonsense. Okay. Let's see here. Where am I in the planning of my slides? Gotta talk about groups. Gotta talk about representations. Oh yeah, I gotta write the Langlands classification. More goodly. How do I write that more goodly? I guess I could look at my own damn notes. Where the hell is everybody? Minutes into stream and not a single person has said hello? Most peculiar. No, this is in chapter 1. Numero uno. Dun, dun, dun. Oh, hi, Mom. Good morning. Love you. Thanks for stopping by. AP Star Plus. I gotta put in here. I'm preparing. These are the slides for my defense that I'm working on at the moment. A P Star Plus. Yeah. Thanks. I hope your day is great. I hope your day is great. There exists this in here, this in here. Such that pi is the unique irreducible quotient of I, P, G, E, mu, tau. Aren't I worried that someone will copy my work? What do you mean? I mean, this is, these are the slides for my defense. So, I mean, this is all stuff that's already online. The preprints are already available. The papers are already submitted. So, if anyone was gonna try to steal it, they could have been doing that like a year ago. But they would have to write the same thing but better, and then have it published before me if they were gonna do that. So Uh, what's a PhD defense? Well, basically, once you finish your PhD, you have to write up everything you learned, everything you figured out, um, and then a committee of experts read the material and suggest edits. And well, hopefully it will be a perfect hair day. Hopefully it will be a perfect hair day. But yeah, they suggest edits, and then you make those edits, and then the actual defense is like 2 hours where they ask you questions about your work, and you have to explain, yeah, what happened. Technically, these slides I'm working on are not for the defense itself, but rather a public seminar I'm giving that morning. Or public in this case means I'm talking to other people in the math department. Defend this special summon a rad attack position. Well, let's see if he appears. let's see how he fares against my timeout button trap card. I feel like I should have been working on these slides like a week ago. I think I could have made a better, more accessible talk if I had. But that's okay. I've tried to give more accessible versions of this talk a million times before. I do want to come back to that integral that you couldn't do. I do want to come back to that. But I think this is where my priorities are at the moment. Yeah. Flux looks like a typo. Yeah, it's not though. I didn't even catch it that it's flux. But no, it is supposed to be like that. I mean, the X, maybe the notation would also be good if I replace the X with a G, so then it would be flug. That would also be sensible. Do researchers stick to Drinfeld-Beilinson GLC? Or Gate-Scory one is more common? I don't know. I mean, one, I definitely don't know the answer to your question because I don't know about their this geometric Langland stuff. You would prefer FUG, wouldn't you, Leo? But I also don't know GLC, Global Langlands Correspondence. Is that what GLC means? This is my Beamer template, yeah. It is indeed. How can I defend that? Well, the Beamer template I'm going to use for my defense is where is it here? I am not working on geometric Langlands. I am working in local Langlands, and I do a bunch of geometry related to that, but it is not geometric Langlands. I don't know why do you hate my Beamer sled so much? This is the one I'm using for the actual 15-minute presentation at the start of my defense. What's a langland? It's a land where there's lots of langs. It's a land where there's lots of langs. Also known as Canada. But I don't know. This looks like. I mean, I maybe don't love these triangles, but I don't know. I don't know why. I think dark mode with the white and blue looks nice. I don't know why this angers you so much, Boris. Swamp green and mud brown? Of course. I'm representing Shrek everywhere I go. It says D modules on Bungie are in correspondence with ind of Galois fields. I'm not sure. Yeah, D modules on Bungie, but ind of Galois fields. I'm not sure that's. I'm not sure that's phrased exactly correctly. Wasn't it like indco on local systems? Indco of the category of local systems on some stack, or is that that's a gate square one, I guess. Ind of Galois fields? Surely you mean at least of the Galois groups or something. The light text isn't visible? What? Huh? In the brown slides? Oh, you mean here? I mean, this is supposed to be light, and then you click the slide, and then it gets filled in. That's intentional. You wouldn't do dark mode? Why not? Why not do dark mode, Leo? Why wouldn't you do dark mode in person? I just want to be a special boy that stands out and looks different. It's end. It's end of the characteristics of mappings from characteristics of mappings. I don't know what that is. I don't know what that is. What's a characteristic of a mapping? Is it in here? Wow, this did not compile correctly. Yeah, where do I find this statement? I've never seen a proof of Poincare duality. Maybe that's something we should do. Yeah, here. I mean, this looks more like what I. Yeah, this looks a lot more like what I'm used to seeing. The derived category on Bungie. There's an equivalence between the derived category of Bungie and coherent G-check local systems, or coherent sheaves on the category of G-check local systems. You know, there was one qual question on the screenshot that you took that was more or less, do you remember all the functors they teach you in algebraic topology? That's a good question. Not really much problem solving, but it went through fundamental group, orientability, Poincaré, and stuff. Dark mode is actually worse for your eyesight? According to who? And what? You know, there's all these myths like, oh, don't read in low light or something. It doesn't actually. I don't think there's any evidence that this damages your eyesight. It can, obviously, it can cause temporary eye strain. What do you call someone who reads applied category theory paper? Yeah, co-author, of course. I mean, the applied, the applied doesn't necessarily have to belong there. Unemployed is also an acceptable answer. The fact that non-commutative geometry, non-commutative algebraic geometry, and Abelian geometry are three different areas of math is diabolical. Yeah. Yeah. Well, is non-commutative geometry and non-commutative algebraic geometry really that different? Are they really that different? I thought those were basically the same thing, if not tied together. I've been asked for an abstract algebra book recommendation, but the student needs careful elaboration of commonly confusing topics like quotient groups. Halufi or Dummett and Foote? To be honest, I'm not sure. I'm not sure which one has the more detailed exposition of quotient groups. But I would suggest that they look at both of them and get two different perspectives, because two is better than one. But also, if they're very confused by quotients, I would have them go back. And really understand the proof of the natural bijection between the set of equivalence relations on a set and the set of partitions of that set. That would be number one. That's the most fundamental. Carefully do that proof without looking it up. Although I have a video on it from like 5 years ago, BT dubs, in my set theory series. If Boris had a real job, he'd know the proof of Poincaré duality by heart. Well, I feel like that's the opposite if he didn't have a job. Local systems are okay, maybe we should do that integral, because we're getting off track anyways. A local system is basically just a family of vector spaces. So a sheaf, so of course there's the constant sheaf, right? So if you have some like abelian group, there's the constant sheaf determined by this abelian group, and then a local system on a space is one for which every point of the space there exists an open neighborhood of that point, such that this is a isomorphic to a constant sheaf. And in particular, a local system, not only is it locally constant, as we would say, but it has the structure of a vector space. So, maybe we fix a field, and this is isomorphic, specifically to the constant sheaf k to the n for some n. Um, and then there's a fascinating equivalence of categories between representations of the fundamental group. I've talked about this a million times on live streams, so if you go back, look through my live stream catalog, you can find more discussion, in fact, some detailed discussions on this. That giving a representation of the fundamental group is equivalent to determining a local system. So yeah, I guess that's it. Now, okay, that's a basic definition of a local system. Of course, of course, what's being talked about in this paper is these are. I mean, this is lock G check. So lock here is actually like a stack, and actually, I think you want to plug in like lock of. I mean, here because here you can insert different varieties into lock. And so actually lock is like a functor in this context, and then what they're doing is the X that they're plugging in, this is actually a stack of Langland's parameters. And so you have to make sense of, you have to take this definition and somehow generalize it to defining local systems on a stack. But then also this is lock G check, so actually you need G check or G hat equivariant local systems. So now there's a whole other layer of complication because now you need this like group action on it. Yeah, there's a lot going on, I guess. But that's a basic idea. Poincare duality. For Poincare duality, there's a Sheafy proof. You don't remember exactly how it goes. We should probably talk about that because part of the whole motivation for like perverse sheaves and stuff is to generalize Poincare duality. So maybe I should look at that before my thing on Monday. If I'm doing OH, I don't know what you mean by OH. Sorry. Can you explain formal schemes? No, I can't. Like the punctured formal disk that remembers nilpotent directions. Your AG knowledge is minimal. You understand why affine schemes is ring up. Yeah, so I don't actually know much about formal schemes, unfortunately. And I also don't know what you mean by OH. Wow, there's lots happening in chat. You heard drinking 10 monsters a day improves your heart health because it makes your heart more resilient. Okay, well, why don't you try that, and then if you're still alive at my age, give me a shout. Indico nilp of G to G of gal to G check. With gal to G check being local systems on LG. LG you mean is the stack of Langland's parameters? But how is a map from gal to G check a local system? Oh. Are you sure about that? Because I think. Are you sure about that? Because I mean, I think that's approximately true, but I think maybe the idea is we actually want to look at maps out of the Vey group. And then I do think part of what the geometric Langlands people are doing is interpreting this as a fundamental group. So it would make sense that you can interpret a map out of the fundamental group into G-check as a local system. Two greater than one noted. Yeah, you guys learn. See how much you learn in these streams. Non-commutative geometry is analysis flavored. Yeah, I know it's full of C-star algebras and stuff, but um, I mean, it was my understanding that there was also AG crossover, but maybe I'm wrong. I mean, didn't it inspire the non-commutative algebraic geometry? I could be totally off base here. You feel like universal properties really cleared up these constructions? Um, yeah, I don't know. Lots of people say that, but that's also something I've never found. To me, I don't know. Quotient groups made perfect sense, and the universal property, yeah, I don't think added any clarity. If anything, it added confusion. But the price you pay, but the benefit you get for that confusion is nice universal properties that help you prove things in a real slick fashion. A quotient group is when a bunch of people get together to do long division. You tell everyone that homological algebra is just waterfalls and puzzle pieces. uh, Something to the extent of quantum planes and studying derivations of them. That comment might have been from a while ago. I'm pretty behind in the comments, so yeah. Non-commutative AG is mostly about QCO and sheaves of modules, right? Yeah. I'm getting to your integral, maybe, eventually. What do we do once the diagrams start chasing us? They might soon. Get ready. Get ready. Be prepared to, I don't know, um, push your diagrams into kernels or something. Locally constant sheaves, so vector bundles. Why so many names? These are not the same thing as vector bundles. These are not the same thing as vector bundles. These are not quite the same thing as vector bundles. Why are they different? In fact, well, I guess a local system is a more special vector bundle. Because I think every local system, you can view a local system also as being. I guess every local system does determine a vector bundle, but even more is true. Is that generally it's a local system with a flat connection. Um, but not every vector bundle is a local system. Actually, let me. Um, yeah, yeah. Well, in fact, the category is local systems is equivalent to holomorphic vector bundles with flat connection. Yeah. Um, yeah. Yeah, vector bundles are not locally constant sheaves. But I mean, they're, yeah. Locally constant also means the transition functions are constant. Uh, yeah, yeah. So it's a more special thing. What's the difference between stacks and motives? I think they're completely different things. No, you feel like stacks of schemes. No, I mean a stack is like a generalization of a scheme. A stack is a generalization of a scheme, basically. But I mean, a motive. Well, I don't even really know what a motive is, but this is more like a. Roughly, you can think of the category of motives as some sort of category of cohomology theories on a space or something. Loch Ness. Surprisingly, I haven't seen that joke a lot, Boris. um. Oh, OH is office hours. I see. I see. I see. Age reveal. It's not hard to find my. If you do a little sleuthing on the internet, you can probably find my age. So, I'll let you. Figure that one out on your own. You're going with a Luffy. Arden's book is giving you nightmares. Well, whatever works for you. I still think you should do what I said, and that is carefully do the exercise that gives you the bijection between equivalence relations and partitions. But what do I know? What do I know? You like Hungerford's Intro to Abstract Algebra as an undergrad. It's quite simple, but very conceptual. You once told your teacher that 0 can equal 1 on zero rings. That's not true, actually. He told, well, uh, I mean, you were wrong, because 0 is not equal to 1 in the 0 ring. The 0 ring just doesn't have a 1. Wait, actually, am I wrong? Am I the one that's wrong? Maybe the 0 is the one. No, oh god, maybe I'm the one that's wrong. uh... Redacted? Yeah, I agree. I agree, Honey England. I would also just like to say, I would also like to go on record saying redacted. Like, wouldn't be surprised if all vector bundles over compact spaces can have constant transitions. Yeah. I also failed pre-calculus in high school, by the way. Not because I tried hard and couldn't understand it. It's because I didn't go to class. Indeed, Boris, that is the benefit of universal properties. Yes, and you should learn the skill of consulting multiple references. Hello, Yaman. Haven't seen you for a while. Welcome back to stream. You wonder if spec of a linear map in AG? No, it's just a coincidence. I mean, okay. Yeah, okay. I was about to say, I'm sure there's some way that you can cook it up. But spec of KT... spec of KT recovers spec T? What do you mean by KT? What do you mean by KT, Leo? Gelfand spectrum? Yeah. I mean, there's some connection there. What do you mean by KT and KX here? What do you mean by KT and KX? What color is the scheme? I think that depends on the scheme. I feel like schemes are like white or black. That's what I feel like. But maybe more particular schemes, like an abstract scheme, is white or black, or maybe even red. Uh, X is red. And if you have a nilpotent on a point, you'll get a fat point corresponding. I don't understand that. Dark blue on black background is unreadable. Maybe. I think it looks nice. It is true, though. Maybe I should go with a lighter blue. Where do I put the colors in here? Dark background, light text. Where's the theorem text defined in here? It's not clear to me where the theorem text is defined. Yeah, I don't know. Are relations defined in terms of sets in natural language relations too? Like above, under? No. Equivalence relations that I'm talking about is different than that. Well, I mean, of course, it's supposed to. I mean, a relation is basically just some sort of thing that associates pairs. And so, yes, you could take these natural language things and formalize them as relations. I saw KT. Oh, by KT you mean KX mod the minimal polynomial of T. I see. And then and then what? And then what? So if I take spec of kx mod the minimal polynomial, then what the points should be in bijection with the eigenvalues? This is what you're saying? Cuz what? It's the by going through the points x minus lambda? Well, one takes k id for id n. This recovers k directly. By definition, you're taking subring of end v generated by t. Okay, let me go back a bit. There's a lot of stuff I'm missing. Dun, 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 dun. Dun, 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 dun. For a local system, that condition I wrote down looked a little like the sheafification functor. No. Wait, what condition that I wrote down? There's nothing to do with sheafification functor here. I mean, of course, you use, if to define the constant sheaf. I mean, the one way to, like, the sort of natural way to build the constant sheaf is to take the constant pre-sheaf and then sheafify. So in that sense, yeah. But beyond that, it's not like local systems are, inherently. Yeah, I mean the sheafification functor is involved, but like then again, not necessarily. You could have some other way of like modeling the constant sheaf or whatever. You think you meant locally free sheaves, not locally constant. Yeah, those are different. You still think that locally free sheaves and vector bundles in local systems sound like the same thing. Yeah, yeah, local systems are locally isomorphic to sheafifications. Oh yeah, you're just answering that question. But you are right. New wave I mean, they're not exactly the same thing though. We get there's like what is it? There's like vector bundles, vector bundles, coherent sheaves, and quasi-coherent sheaves, right? And is something like this, right? Where's Vakil? Where's Vakil? Quasi-coherent sheaves. Yeah, vector bundles, locally free sheaves. Rank and vector bundles, transition functions. Yeah, I mean, first off, a vector bundle is not a sheaf. The way you pass between them is taking the sheaf of sections of a vector bundle. F is a locally free of rank n. Invertible sheaf, locally free sheaves on schemes. Dun, 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 dun. Yeah, here we go. Here we go. Locally free sheaves, quasi-coherent is properly contained in QCO, properly contained in OX module. Sorry, that's what it is. But we also have this finite rank locally free sheaves. Right. And the finite rank locally free sheaves, these should be equivalent to vector bundles. Is that right? Is that right? Geometric vector. What do you mean geometric vector bundle? But I guess that's right. Yeah, 0 is 1 in the trivial ring. I guess I'm being dumb. General question: how did math proofs used to get done before Frege? If they didn't have modern logic? What do you mean? We had logic. People still had logic before Frege. Frege didn't invent. I mean, like I guess he invented like the most modern version of logic, but we still had logic way before Frege. Yeah, my English in high school, I went in. The lowest mark you could have was 34. It was actually not possible. Like if just for signing up for the class, you got 34 out of 100, and I had that because I literally didn't do any homework ever. And then I went in and I wrote like a 96 or something on my exam, and it was just enough for me to pass. You thought locally constant sheaves were sheafification of any constant pre-sheaf? No. That's a constant sheaf. Constant sheaf is sheafification of a constant pre-sheaf. The local systems are only locally constant. Definitely not globally constant in general. But of course, a constant sheaf is a locally constant sheaf. But when did math proof start? Well, at least with Euclid. I mean, they started at least with Euclid. Euclid's like the first sort of proper book. Gelfand duality tough. They just did them. Yeah. You mean in arithmetic and algebra? Yeah, I don't know. They also just did them. You're supposed to read this paper on categorified Gelfand Nymark, but that was 20 years ago. Oops. How was my Erdish number 2? Same as Terry Tao? Because in my undergrad, I did research. I did a summer research thing in my undergrad that led to a publication, and it was in graph theory. And the person who was my supervisor, whose name is also on the paper, she had, I think, 2 papers with Erdish. Yeah. Wouldn't be surprised if the name of Spec R comes from Spec in-ear operators, huh? The original proof of the infinite number of primes involves a string? What? I've never heard of this. I've never heard of this. Original proof. I don't believe you. Oh, a string in the sense of like Python? Is that what you meant? A string of characters? I don't. Yeah. So they could prove statements like for all x, f of x, or there exists x such that f of x. Yeah, they just didn't have the same. They just didn't have the formal symbology. They never tried? What do you mean they never tried? Yeah, I mean, they maybe didn't state things in the form for all, but, you know, they definitely would prove things like if n is an integer greater than 1, then blah, blah, blah. Yeah. That'd possibly give too small dimension over the total vector space. They couldn't prove universal statements? Yeah, of course they could. Of course. They proved you know, the fundamental theorem of arithmetic. So yeah, they did. Where are we here? Wow. This may, for real, I say this a lot, but for real, this may be the first time I don't make it to the end of stream, to the end of comments by the end of stream, unless I skip more of what you guys are yapping about, which, you know, maybe I should. Yeah, I saw that, Boris. I saw that quote from Schultz. Yeah, I'm gonna skip a lot of your yapping. Wait, what's this? So yes, if you'd want all the multiplicity data, you'd go to kx mod characteristic polynomial. Okay. How about this? How about this? Let's just ask Google. Let's ask N category cafe. Did I learn harmonic oscillators and quantum harmonic oscillators? A little bit recently in my quantum stream. How did they be before alphabet? Yeah, of course they could prove things like n squared is even if n is even. Of course they could prove those things. Are you 30 to 33 years old? Not a bad guess. Not a bad guess, the real deal. Not a bad guess. Gatescory's definition of Q code doesn't need any niceness properties? Well, what do you mean? One could say that QCO is a niceness property, no? A niceness property of sheaves. A vector bundle is not a sheaf is very much so splitting hairs. Yeah, I mean, well, yeah, I don't know. Maybe you're right, but I don't know. This is a thing that bothered and confused me when I was younger. I don't know. Is a local system a representation of the fundamental group? I mean, kind of. They're equivalent. I guess if we're doing homotopy type theory, then these are the exact same thing. And a homotopy type theorist can't tell them apart because they're isomorphic, so therefore they're equal. I don't know. When we say X is not a sheaf, we're usually talking about a pre-sheaf and saying it doesn't follow a sheaf axiom. Hi, Maddie. I was talking about life in the start of my last stream. I was indeed. Yeah. How did we do logic? Yeah. Why do all the mathematicians yap about philosophy like this to some degree? Well, because, I mean, mathematicians and philosophers are both people who like lying around staring at their belly buttons all day. And, so naturally we're going to hit on the same topics. Learned a few things you didn't know about me. I was wondering, Mom, what are you saying that in response to? What are you saying that in response to? What did I say that made you say that? I don't know when you made that comment. I'm so far behind in the comments on stream. Yeah. Caring about philosophy. You guys use dish soap? Yeah. I carry that thing with me everywhere I go. Got a little holster on my belt for a little portable dish soap container. Yeah, Arad just buys new cutlery every single time. Disposable chopsticks. That's all of Arad's cutlery. There was a person who used soap. Why would that make someone bald if they used soap instead of shampoo? Uh, yeah, I'm just skipping most of what y'all are yapping about now. I want to read this article. Mrs. Uh, well, Mrs. K Theory would be my future wife. Mother K Theory would be my mom. Mother K Theory. Um, you met the inventor of homotopy type theory, Steve A. Wody, at a pub in Cambridge last week. Wow. There's a really great interview with him, by the way, on the About Logic podcast on YouTube. You asked him about derived functors. He said it's the functors which extend to the infinity category. God, what an answer. uh, you're catching up at triple speed from Berlin. Wow. Wow. Wow, catching up at triple speed. You paying for that premium so you can get that 4x YouTube speed? Okay, now that we're caught up in comments, time to fall behind while I read this. Many uses of spectrum. I'll explain how the story goes. Although it's motivated my desire to set up various notions of spectra, it doesn't actually mention spectra at all. Got an operator, right? Whoa. I didn't know. I don't know what I just did, and I didn't know I could do it, and I don't know how to do it again. What is the significance of this ring? Let me explain. The kind of answer I'm hoping for. Suppose we replace it with a minimal polynomial. Precisely right end V for the K algebra of operators on endomorphisms with composition as its product. Sending X to T has this as its kernel. And the image is the subalgebra generated by T. Hence, this is isomorphic to subalgebra, which consists of polynomials on T. Okay. The spectrum is a set of its eigenvalues, but should really be thought of as a set with multiplicity. Usually people define I explained in a more conceptual way to think about multiplicity. It's the dimension of the eventual kernel of this. Okay. When you write your last... It's Pi Day. Oh, it is Pi Day. It is Pi Day. Right. Yesterday we did have a celebration in my department. Yeah. I guess I'll take a quick break to tell you my favorite pi fact is that the probability... There's a very old, very bad video with weird audio, but the probability that two randomly chosen positive integers have GCD1 is 6 over pi squared, being the inverse of zeta 2. That's my favorite pi fact. And you basically prove this using the principle of inclusion-exclusion. In any case, characteristic polynomial is this. These are distinct eigenvalues. We can form this ring. For every ring, there's a spectrum. Set of all prime ideals. Given the operator, we get two things. How are they related? That's the question. This answer was worked out long ago. I guess all algebraic geometers know it. Makes sense. I'm not an algebraic geometer. Nevertheless, I think there are plenty of people who know both uses but aren't aware that there's a connection. For a ring, the mere set of prime ideals is this. Are we working over the complex numbers? Do we need to be working over the complex? I guess we need to. Yeah, did we say that? Did we say our field is algebraically closed? No, just over a field. But this seems to be assuming seems to be assuming we can totally factor a polynomial. Whatever. You just wrote some code to solve quintics and show roots of unity as radical expressions. But if we can do, how does your code work? Like your code uses a Galois theory to figure out if it's not solvable. And what does it do if it's not solvable? Are you doing some Schoenhaus stuff in the code, Nadia? He did take closed? Oh, I guess I miss it. I mean, I guess whatever. To talk about this, you can pass to the closures. But I mean, like it'll only be linear factors if you can factor it. I don't know. I guess you could still take this. I guess this quotient still makes sense. But this should be the product of all of them, though, right? Okay. As a topological space is discrete, a sheaf of widgets. I don't know what that means. A sheaf of widgets on a discrete space is an S-index family of widgets. Here, widget is ring. What? Why are you saying the word widget? Okay. So describe the sheaf this is equipped with. We just have to describe the one ring. And in fact, the ring associated to this point is this. Now the point is you can recover the multiplicity from the ring. At least you can do so if you're allowed to know its K-algebra structure, because it's just the dimension over the vector space. Okay. Thus, even if you don't know T, spec T tells you what spec RT is and vice versa. They tell you equivalent information about the operator. That is satisfying, but one question remains. How do we understand the ring RT? As I just said in the beginning, it would be easily understandable if we had used that instead of that, but then the spectrum would tell us the powers in the minimal polynomial rather than the characteristic polynomial. Okay. Maybe an example will make the problem clearer. In fact, a really trivial example would do T is 0, boom, bop, bing. I see. So conceptually, what is the process that turns the operator on Kn into the ring? And we're just going to leave on that question? Okay. Okay, fine. Okay, fine, whatever. If it's not closed, you can still do the same process, and the quotients will give you the extensions that you want. Okay. Oh, it's below the evaluation kernel line. Okay. What's the T with Grosvenor bases? You've heard is great for computational stuff. Yeah. Same here. But yeah, I know about as much as what Nadia just said, that they're well, I don't know what slow code means. Grosvenor bases are easy to write slow code for. But I know they help us compute stuff in rings. Starting with KT, because this is something you can immediately summon, just like how you summoned a rod earlier. There's a little bit of a delay on that. You should check your summoning settings. There's a delay between when you tried to summon a rod and when you showed up. What's the answer to the final question? I don't know. Maybe Leo can tell us. You actually did Grosvenor basis code to help with simplification in the radical code. That's interesting. But yeah, what does your code work? It implements some Galois theory to determine if it's solvable? Uh, and then what? It uses the group theory to find the roots? And then what? Does it just spit out not solvable if it's not solvable, or what? If you do min polynomial, you can just go to spec kt and bam, your process is getting you where you need to go. I'll be honest, that was extremely unhelpful. Hello, Teddy. It's been a while. You've been wondering what strategies do I use when studying something in math that's really dry. Yeah, I don't think I have any strategies. If I have to do it, then I don't know. I just grit my teeth and do it. I don't know. Have a cup of water alongside? Yeah. Yeah. What do you have to do when, I don't know, you have to do laundry or something boring, or I don't know. What do you do when you have to go to the dentist? Because the dentist sucks and is boring. You just go. Because you don't want your life to suck. Yeah, I don't know. I don't have any particular advice. You just gotta sit down and do it. How do you study math when your classes get in the way? Easy. I mean, the strategy I tried when I was younger was not doing my homework. Strategy I tried when I was younger was not doing my homework, and that didn't go well for me. So don't do that. The difference is whether you want your thing to act differently on t and t plus t. Yeah, I gotta tell you, Leo, your messages. I don't understand what you're saying. You'd also lose data if you have degree 2 nilpotency at lambda plus 1 degree. Yeah. Anywho, yeah, and I also have no idea what a rod is on about either, and that's okay because I don't need to. Do I think if you perform mediocre in Cambridge Part 3, PhD applications next year would be less successful than with your good undergrad grades? I don't know. To be honest, I don't know. I don't know how valued Cambridge Part 3 is. Of course, it's famously difficult. But yeah, I really don't know. So your undergrad grades are good? I'm a little confused though. Cambridge Part 3 is part of your undergrad, right? So are you wondering if you should drop the course before you get a mediocre grade? I don't know. Yeah. I mean, not knowing a ton about Part 3 other than it's famously hard, I can imagine that if I was on an admissions committee, I would maybe look at a mediocre Part 3 grade and I would say, well, it's Part 3, so that's not so bad. I don't know. But maybe someone else who's looking at it more quickly and doesn't know, they would look at it and go, oh, that's a mediocre grade. Put it in the no pile. I don't know. A high school student on Discord asked about trig functions at rational multiples of pi being expressible as radical functions. Okay. Isn't part three the equivalent of masters? I didn't know that. I didn't know that. Oh, it's considered an undergraduate master's or fourth year in the UK, because most undergrads in the UK are 3 years on. Okay. Yeah. So this is news to me. This is news to me. And depending where you go to school, that might also be news to people on the committee. So I don't know. You at Berkeley for undergrad? Damn. You can do part three as a master's student externally, have your exams in June, and just low key kind of stressed. Well, if your exams are in June, there's a lot of time between now and June. So I would just, I don't know, just grind. Grind and do your best, and it'll probably be okay. If you're a Berkeley undergrad that attempted part three, I can only imagine that you'll be okay. But I don't know. Yeah, you should ask someone who's been on an actual admissions committee. Um, you fortunately got fluent in English before university. That sounds like a plus. If you went to an English university. Yeah, the stream is so long. I'm gonna go. I should go. Thanks for bringing it up. Now it's time to go. Yeah. All right. Well, June is 1 month, basically. What are you talking about? What are you talking about, Boris? Boris, what is this? What is this nonsense you're talking about? April isn't real, right? I mean, the whole first day of April is a joke. The whole first day of April is a joke. And May doesn't count. I don't know about that. I don't know if May doesn't really count. Anywho, it is time to bid you all a very fond QED. QED. QED.